What's up guys, and welcome to this new video about end-to-end testing in Android. In this quick video we will build a little example application where the user can navigate between three different screens, and he can also click on a button which shows the text and can hide it after that. And we will validate that this app works properly with so-called end-to-end tests. First, what's actually an end-to-end test? An end-to-end test is a test of your application under product-like circumstances. So how the user would really interact with your application. This means, for example, clicking on buttons, tap gestures, text inputs, and all that kind of stuff the user can do with your application. And the underlying business logic is normally already tested at this point. This is why this video will be only focusing on the UI elements test, assuming that we have an underlying working business logic. Also, for the sake of simplicity and because we don't have any dependencies or underlying business logic, we don't do dependency injection setup in our test environment here. But let me know if you're also interested in that. Then we can do a more complex example in the next video. Alright, okay, I'm here in an empty Jetpack Compose project, and I would like to start building the little example app first, and after that we will set up our test environment and write the end-to-end test. First, we need to go to our build.gradle file because we need one additional dependency for Compose navigation. So just insert this dependency, and then we can go to our root package and create a new Kotlin file called navigation. And we will set up our navigation composable so that it's really testable and does not depend on anything. So the whole navigation logic will be kept inside this navigation composable. You will see that we can then set up our test later in a really easy and simple way. So let's create a composable navigation, and in here we will have a nav controller is equal to remember nav controller, and remove this parameter. And then we also need a nav host. We will pass our nav controller, and we need to define a start destination. And to represent our different screens, we can create a sealed class. And the first object of the sealed class will then also our start destination. Let's call this screen routes. We will have a parameter val route of type string, and then we have three different screens. The first screen, which inherits from screen routes, the route will be first screen, and then we can just copy this line, paste it down below 2 times. This will be the second screen. Let's also change this parameter. Then we also have the third screen and the third screen for the object name. Then we can pass our start destination. This will be our first screen dot route, and we can open this nav graph builder scope. Before we can define our different composables inside this nav graph builder, we need to define our screens. Let's start with the first screen, which will be a file. Of course, composable first screen, and this takes one argument on navigate to next screen. And this will not take and not return anything. And this function here helps us to make also this first screen more testable. In case you want to test it more in isolation later, then you just need to provide a function for this on navigate to next screen. Because I also did this mistake in the past, I passed the nav controller as an argument like this, and then somewhere on a button click I said nav controller.navigate to a specific screen. But this is not that good practice, since then the first screen depends on the nav controller. It needs to know the nav controller, and with this approach, with this on navigate to next screen function, we can go to our navigation and say something like this: composable screen routes dot first screen dot route, and if this screen route is actually navigated to, then it invokes our first screen, and here we can then provide functionality for the on navigate to next screen. And here we have access to this nav controller, and here it's fine because we are in a navigation composable. So we can say nav controller dot navigate screen routes dot second screen dot route like this. And then the navigation works properly, and inside this first screen we don't need to know anything about our nav controller. So this is a really fine practice, which is also cool when it comes to tests. Then we can go to our root package again, create a new file for the second screen. And here I think we can just copy and paste this and make some adjustments. Here we will call second screen, and on navigate to next screen remains the same. And then we have also a composable for the third screen, which will be also a file, composable third screen. This does not take any function as a parameter, because when we are in the third screen, then we won't navigate to any further screen. Okay, let's go to our navigation and define the composables for our screen routes second and third screen. Here we say composable screen routes dot second screen dot route, and when we navigate to this screen, then we can again just copy this, and here we invoke the second screen and paste it like this, only that we navigate to the third screen. And in case if we navigate to the third screen, then we invoke the third screen composable like this. And then our navigation is set up and we can start building our screens. Let's start with the first screen. Here we will have a column as the root composable, which takes a modifier. Let's import this column, and this modifier will fill the max size. Also import modifier, and it will have a little padding of 15 dp. And then we have a vertical arrangement, arrangement.space between, and a horizontal alignment, which says center horizontally. And one important thing before we actually continue is to insert some string resources. You will see when it comes to testing later that the string resources can be really important for the sake of consistency, and also if something changes in the future. So let's go to our resource folder, the values strings.xml, and here I have some strings, and I will also upload this to my GitHub's repository so that you can just copy and paste those strings and don't need to type them off. Then we can go back to our first screen, open this column scope. First we will have a text. Let's import that. For the text, we will have a string resource r.string.firstScreenDescription. For the style, we will say material theme.typography.h2. The modifier will be set to modifier.fillMaxWidth, and we will set the text align to center. So text align dot center. And below this text, we will have a button with an onClick method. Let's import button first, like this. And in here, we will invoke our onNavigate to next screen function. And the button will also just have a simple text. This UI won't win an award here. This is just for demonstration purposes so that we can use it later in our test cases. Here we will also have string resource r.string.navigate to second screen. Alright, okay, let's continue with our second screen. There we will basically have the same UI components, just two additional components which provide a little bit of a toggle functionality, which we can then test later. But we can copy this column, go to our second screen and paste it down here. And let's adjust the string resources. Here we have the second screen description, and for the button we will have navigate to third screen. Then we have a little state var show detail by remember, mutable state of and false by default. I think we need to import for the delegate here. And then we also have additional components. We will have a button with an onClick method, which toggles the show detail state var, and the button's text will be string resource r.string.button show details. And then below this button we will have a little if check, if show detail, then we will show a text with a string resource r.string.second screen detail text. So really simple, just some toggling. If this button is clicked, then the text appears, and if it's clicked again, then it disappears after that. The third screen will be even more simple. We can go in here, still have our copied first screen. We can remove this button and adjust the text string resource. Here we have third screen description, and then we already built all the screens we need. The only thing that's left is, let's close them, invoke our navigation composable inside our main activity, so we can remove this default stuff and invoke our navigation like this. And then we can start the application. As you can see, really great UI with a nice description and a button at the bottom. When we click on this navigate second screen, then we are in the second screen. Here we can click on show details. This will toggle our description. Click on show details again, then the description disappears. And when we click on navigate third screen, then we are at our last screen, our third screen. Alright, okay, before we start setting up our test, let's have a look at these two modules. We have on the one hand this test module, which is for plain unit tests. This isn't used here because our tests require the Android operation system and thus an Android emulator. The unit tests normally are for business logic, like use cases where you only need to test logic which runs purely on the JVM. Here in this Android test module, we have access to the Android environment, so the Android operation system and an emulator to run our UI tests. And you could also run tests which require other Android specific things like the context or something like this. Doesn't need to be limited to the UI. Let's also differentiate between instrumented tests and end-to-end tests, what we do here. Instrumented tests are normally smaller. There you only test one or two composables in isolation or other context-related stuff, and you don't really consider user scenarios. This could be, for example, clicking on a toggle button and then a corresponding text shows. This would be a test for an instrumented test. An end-to-end test, on the other hand, tests whole user scenarios, like real production-like circumstances, navigating between different screens, text inputs, saving, navigating back, all that kind of use cases that provide a real value to the user in a real production-like application. Alright, okay, enough talking. Let's go to this root package inside this Android test directory. Click on new Kotlin class and we will call this end-to-end app test. The first thing we need is a so-called compose test rule. This compose test rule allows us to set compose content and also to access the activity. We can annotate this with @get :rule. Well, compose rule is equal to create, and here we have two different possibilities. Create compose rule if it's only about setting compose content, in case you want to do instrumented tests and only want to set a specific content for a composable, then you could use this, but we will use the create Android compose rule because we also need to access the context through the activity, because we have string resources and we need to access them later. Let's select create Android compose rule, and for the generic type we will pass the main activity. The next thing we need is a setup function, which we can annotate with @before. This makes sure that this function is always called before each test case. In case we have later 5 test cases, then this before function gets called 5 times, each time before a specific test case gets executed. And this is really helpful because we want to provide kind of the same state, the same screen before each test case starts in here. Here we can say compose rule.activity.setContent like this. And in here we also can use our theme. In case you do theming, then you could wrap this around your content. And here we only need one line with our navigation. This will invoke our navigation like we have in our main activity here in our production app. And now you can see that this is really powerful that we did it like this with the navigation composable. Otherwise, if you would have defined the navigation in here in this main activity, like I also did at the beginning, then you would need to copy this and need to paste it in here. And with this, we have a real clean approach to solve this. It can be also the case that you only want to consider 1 or 2 screens of your application for this specific test class. Then you can also provide custom test adjusted navigation composables. For example, you can create a new Kotlin file called test navigation for use case 1, for example. Then you create this composable test navigation for use case 1, and in here you provide navigation logic only for 1 or 2 screens which you want to test, and then you can go back to your test and invoke this test navigation for use case 1 and provide it like this, and then the end-to-end test starts at this specific screen, only contains the screens you defined here. But for this tutorial, we want to test the whole application and the whole navigation logic inside this application. So it's fine to invoke this navigation composable. Then we can define our first test, add tests, function test app navigation works properly. This is the first test case I would like to write. It just tests if we click on our different buttons for the navigation that we get navigated to the right destination. First, we need the context, which we can get from our compose rule.activity.application context. And then we can make use of our compose rule in terms of actions, assertions, and finders. Such a compose rule interaction or compose rule usage has always the same principle. First, we need to find a specific node, then we can make an optional action on this node and also an optional assertion on this node. Because in the background, this is represented, or all the composables are represented as a semantic tree. That means that each composable is represented by a node within this tree, and we can access this node with this compose rule. Let's start with our first usage of this semantic tree, compose rule.onNodeWithText. We can also search a node by tag or by its content description. This tag can be applied or can be inserted with the modifier in the production code, or you also maybe know the content description when you have an image composable or an icon composable where you need to provide a content description. Then you can also find a node with this content description. Sometimes the text is not available because the composable is not a text composable or a button composable, and sometimes the content description is not available. Then you maybe need to provide a specific tag, but you can do this with the modifier in your production code. Here we can use onNodeWithText because we want to first have a look if we are in the first screen, just to be sure. And here we can then say context.getString, because we work with string resources, r.string.firstScreenDescription, assert that this is displayed. Let's also rearrange this a little bit so that it's more readable. So you can now see we first apply a finder to find a specific node, and we look for a node which has a text with this first screen description. And after that, we don't do any action because an action is optional, but we assert something. We apply an assertion. We assert that this specific node is displayed. And this first screen description string is used in our application, in our production app application, at the first screen at the top. So this should find this node, but maybe we have messed up something. Then we will find out when executing this test. And the next thing we want to do is compose rule.onNodeWithText again. This time context.getString r.string.navigate to second screen. This is our button at the bottom of the first screen and should be found with this finder. And here we can also apply an action. We don't always need to apply an assertion. We can apply an action, and I would like to perform a click on this button. And then it should click on this button and navigate to the next screen. But we don't know if this navigation to the next screen actually was successful or will be successful in production. This is why we need to check it. Let's copy this compose rule from above. This time we will check on the second screen description, because if this node is actually displayed, then we can be sure that we are actually in the second screen and that this perform click actually worked and navigated us to the second screen. Then we copy this compose rule, paste it down below, and at this point here, we are currently at the second screen, and then we can click navigate to third screen. And again, we want to check if this navigation did work properly. So we will check on the third screen description like this. And then we are good to go to try this out. So this will just check if all the navigation stuff works properly. One thing I would like to mention before we actually start this test case is regarding this string resources usage. I hope you see why they are so important. If not, imagine if you use hard-coded string values for your production code and for this test code. And then you change your production code, then this test case would fail only because the strings now differ from each other, causing you to have a look at it and first don't know what's currently going on. You maybe think you messed up your code or something like this, but the logic still remains the same. The test only fails because the strings are not equal anymore. And this is why you should always use string resources for that. Of course, in each production app application, you should always use string resources, but here you can see their importance. All right, okay, let's click on display sign, run test, and then the emulator should go up and we can have a look. And this will run really fast, so maybe you can't even see the clicks, but maybe you can indicate them a little bit. Okay, this was it. Really fast, and yeah, it performs all the clicks. And we can also have a look at here, and we can see that the test passed. That means that everything works as expected. I would also like to create another test case for the button we defined in our production code where the text display is toggled on the second screen. We can annotate this again with add test, function test navigate to second screen, show and hide details, like this. And let's remove this typo. First, we again need a reference to our context is equal to compose rule dot activity dot application context. The first thing we want to do is to perform a click at the button to navigate to the second screen. We already test for proper navigation on the test case above, so we don't need to check if the navigation itself to the second screen actually works. So we can straight start with compose rule dot one node with text context dot getString r.string dot navigate to second screen, and then we can perform a click. And as I already said, we don't need to check if we are actually in the second screen because the test case above covers that. Then we say again compose rule dot on node with text context dot getString r.string dot second screen detailed text. This is the text of the second screen that can be toggled, and we want to assert that this does not exist initially. Call it whatever use case you want. It's just my definition of how this should work, that this text is not shown initially. After that, we again say compose rule, and I think we can just copy this from above. Compose rule on node with text, and this time we have the button show details, and we want to perform a click. Then we can copy this and paste it down below. As you can see, this is a lot of copy and pasting, but this is always the case when dealing with tests. So here we change this to second screen detail text, because now the text should be shown. So we say assert is displayed, and then we again perform a click with this button. So paste it down below, and then we can copy this one here and paste it down below, because after the second click of the button show details, we want to assert that this text here is not shown anymore. All right, okay, then we can start this test case clicking on this run sign, and maybe you can see what's going on, but I think this is again too fast to see if the text is actually, yeah, okay, if you had a close look, then you could have seen that it was visible for a short time, and we can also check if the test case actually passed, and this is the case, so everything is fine. And for the whole check, we can also click on this run sign at the top and run both test cases. Let's have a look. Also, if the setup is correctly after that, yeah, maybe you have seen it. We have 2 times this setup function executed because it then started at the beginning for the second test case. Alright, okay, this was it for this video. I thought I only need 15 minutes. Now I'm almost half an hour. But, well, okay, I hope it was not too boring building this example application, and I also hope that you could learn something about end-to-end tests. In case you want to learn more about end-to-end tests, let me know in the comments. I can obviously provide more complex examples where we also need to set up some dependency injection with Dagger Hilt only for our test environment. So yeah, if you're interested in that, let me know, and we will see us in the next video.